Our next speaker is Eric Ries from Toshiba Memory. He joined Toshiba Memory in 2013 as a general manager of corporate development and strategy for semiconductor and storage products company in Tokyo, and then returned to the US in 2016 as senior vice president for memory and storage strategy. The Memory and Storage Strategy Group explores methods and technologies to better integrate memory with storage and storage with software. The mission is to create a more compelling and fluid way to manage data in the world where systems are now scaled and integrated in an unprecedented manner. Please welcome Eric.
Thank you, Mark, for that kind introduction. And it is my pleasure to be able to talk to you all today. And I appreciate SNIA organizing this conference and giving me this opportunity to share some thoughts with you, particularly how at Toshiba Memory we're working to be a driving transformational force in storage. And with that introduction, first things first, I do have an announcement for you all here today. And I'll hark back a little bit to what Mark said. I hailed here originally from the Tokyo headquarters where I was part of what we called the semiconductor and storage company. And that was part of this big conglomerate called Toshiba Corporation. And we can provide you nuclear plants, and we can provide you NAND flash, and a lot of things in between. Well, all good things have to come to an end. And last year, Toshiba Memory spun out from Toshiba Corporation. And it's been our distinct honor to be able to carry that Toshiba label, that Toshiba brand, for another year while we got ourselves organized. Well, next week on October 1st, our name is going to change. And hopefully, after I unveil our name to you, if you haven't read it in the press already, it'll make a little bit of sense to you on where we're going to be going in the future. But drum roll, please. Our name will be Kioxia Corporation. I heard a giggle already, so I challenge any of you to say this as fast as you can, well, 10 times in 5 seconds, and see if it comes natural. Hopefully it will. The name actually has some good thought behind it. We're a Japanese corporation, and so we need to maintain some of that heritage. So our name combines a Japanese name for memory, or Japanese word for memory, and in the Japanese language there's multiple words that are available to express memory. But one of those is this one, which is kyoku. And kyoku embodies memory in a broader sense, and more in a humanistic sense. And we've combined that with the Greek word axia for value. If you don't mind me getting serious for a moment here, and I'll share a personal thought. Some of you may share this, but my mother suffers from debilitative memory issues. And one very sad thing about that is, sorry, this is a downer, I'm supposed to be an upbeat speech here, but you lose your identity over time because your memories are part of your identity. And those memories bring value to who you are and what you do. And that's the same for a human being as it is for a corporation, it is for anything. And that's what we're trying to express in our name, not debilitative disease, but actually the value that memory brings to our lives and to the things that we do. And that's why we're using the word kyoku as part of our name, kyokusha, to show to the world and to ourselves that we are embodying the value of memory and what that brings to ourselves, what that will bring to you. And also that we will continue researching into the areas of memory beyond just simple NAND flash. So, for you Monty Python fans out there, now for something completely different.
Silly walk?
No, I won't do the silly walk, I'm sorry. But we can do the argument one if you want. My legal department took all the fun out of here. I wanted to have one of those Terry Gilliam animations, particularly the one where there's this guy's bird head, and this guy's coming like a bird out of a nest with his head open like a clamshell. And there's this fish flying along into his mouth. And that fish was going to have the word enterprise on it, because the cloud is taking over enterprise and the guy was going to be the cloud. But instead, we'll have to go with the fish and the shark here. But the idea that my legal team quashed, but we still, I think, achieved through this animation or through this illustration, is that data centers are in motion. Our electronic world is in motion. And there's a shift going on. Not too many years ago, I guess I shouldn't use names, but there was big corporations that that embodied the idea of storage, and that was in that enterprise area. Now we're moving where cloud is really taking over so many things that we do. And the traditional dichotomy of enterprise storage versus the other stuff is going away, where that other stuff is going to be public, private, sorry for the preview there. Private, hybrid, and other these things, they'll coexist, but in a slightly different nature. Another good thing about this illustration is enterprise up until now has been this big, powerful thing that dominated. I don't know if carnivore is the right image or not, I don't know. But big and powerful presence within storage. But we have all these little fish, these little things that are coming together as that cloud. And to continue to abuse this metaphor, even though they look huge and imposing and are scaring the shark away, any of those individually can't take the shark out. And as a group, they really can't take the shark out. They can overwhelm it, disorient it. And I don't want to abuse this so far to say that the cloud is going to disorient and abuse mentally abuse a shark. But things are changing, and it's no longer going to be the number one dominant thing in the world. And this graph hopefully will show that. This is looking at data traffic, cloud versus traditional data center. And even in the historical realm here to this future forecast, the amount of traffic just isn't even comparable, and it's growing very quickly, up to where we have, 20,000 or so exabytes of data that's going to be flying around. Now, some of that's going to have to be stored. Probably a lot of it will have to be stored. Some will go into permanent storage, some will be hot, some will be medium, and whatever we decide, and whatever you as developers decide to categorize it as. But that will be stored. And the majority of those exabytes, be they hard drives or hopefully flash, in our case, they're going to be going to the cloud vendors. That's just the way it's going to be. It's no longer going to be the enterprise that's going to be driving all of that. And when I break that down into flash itself, well, the cloud is going to be, according to Forward Insights, by 2023, roughly 60% of the bytes that are going to be shipped in flash will be going to the cloud. Kudos to the enterprise guys. They're still there. They're still significant, but the driving force is shifted to the cloud. Now, of that, I'm going to now ask you to forget about the fish metaphor. That cloud is not made up of a bunch of little guys. There's actually 3 or 4 really big guys and then a lot of little guys. And those big guys are what we like to call, in the most friendly terms, hyperscalers. And most of those bytes are going to be going to hyperscale. Now, one other thing about our friends, the hyperscalers, they don't use storage the same way that has been traditionally used. The hyperscale cloud storage paradigm is application-driven, software-defined. And the drives that my company is shipping today, that my competitors are shipping today, are not necessarily of that nature. Sorry, I missed a slide here. Not necessarily of that nature. But there is that gap. The industry hasn't filled it. And so the hyperscalers have taken it on their own and begin to define. They have, I shouldn't say begun, they have been defining their own storage devices. And in some cases, they've been building their own, because their usage model is different. These devices, they're host controlled, they're application driven, and highly integrated into the stack. With the typical SATA drive, that may be difficult for you to do right now. Thus the new definition. Another reason for them doing this is flash continues to grow in its share of the storage that's being used by the hyperscale providers. There is a lot of flash unique processes that impact their business. Some of these processes are garbage collection, data placement, and wear leveling. Each of these play a different role in affecting the quality of service or the value or the service that the hyperscaler can deliver. In the old world of the spinning disk, latency was a pretty consistent thing that could be planned for. Unfortunately, with solid state storage, it's not quite that way. Schrodinger's cat likes to pop out every once in a while and confuse things. Or more typically, the drive has to go do some business and then it'll come back online. Data placement as well. As you're architecting your software and your applications, you categorize your data in certain ways and you need to place that in an environment where you'll get it back predictably. So these are all elements that we've noticed in the hyperscale world are very important and that need to become more available to the developer. And I'm not telling you anything that you don't already know. I've had these conversations on the side with many people, but it's always kind of been this why can't they, why won't it be world. And as hyperscalers are pushing the envelope in one area, our storage as a device has been continuing to evolve in its own pace. For so long, it's been just rotating rust. Let me go down memory lane a little bit with you. And I will be betraying my age a little bit here. But there was once that day when the first hard drive, well, this one precedes me a little bit. The first hard drive was developed by IBM. And when you wanted to move it from location A to location B, you had to put it on an airplane with a forklift and then take it off with the forklift. And I think that was 5 megabytes. Is that right, Scott? Eventually that transferred into something that I remember, which is a cassette deck. I remember my friends and I playing around with Commodores and recording our routines on a cassette deck, and then that moved to a 5 1/4 inch floppy, and then a 2.5 inch cassette, and on we go. But the consistency here that I want to pull this back into the theme is that there is all some kind of media, magnetic-based media that was being manipulated. And that created a bottleneck because you had to translate things to be able to get it magnetized, and then you had to read it back and you had to translate it back. And in storage, there was, in our recent lifetime, an extremely innovative change, and that was when NAND flash was turned into a drive. Then all of a sudden, the great wish that everybody had, why can't my media move at the same speed as my interface? That happened. Actually, the media can move faster than your interface. And I think many of you probably joined me in rushing out to the store to get the first SSD that you could put into your PC, and wow, all of a sudden your PC moved faster. And that happened in the data center, and that happened every place else. Well, in the hyperscale world, and they're leading us, and when the rest of us will catch up there, they're already saying, this interface is too slow. Why can't my application move at the same speed as the media? And unfortunately today, solid state storage, although it is digital, it can move faster, we're still having to deliver it as a drive. It still has to behave as a drive. And all of that implies both the good and the bad. The good being also consistency, standardization, call out to the standards group that has performed this, put this thing together. And lest I be misunderstood, today's speech is not a call against standards. Definitely not. But a fresh look at the paradigm that solid state storage must be enabled for software control. It's digital, your world is digital, they need to come together. And guess what? The hyperscale guys are already doing that. We've already talked about how they're defining their own drives, their own way of doing things. And it is to take advantage of that digital nature, or to put it another way, to take away the roadblock that that is there because they have to pretend you're a drive. So we as storage vendors need to pay attention to that. And today is kind of a call out for us to be able to do so and to start doing so. And to you as developers to push us to keep doing that. And the cloud is continuing to push innovation. We'll push it in storage. It's pushing it in our lives. We see it in analytics. We see it in finance. And please forgive me for using such a popular buzzword, but it's even AI. I really fought putting AI on there because it seems like everywhere you go, every startup has something that has to do with AI. But AI is here to stay, and it is driving innovation. It's driving it in the cloud. It's going to be persistent in the cloud. So to bring this back a little bit, innovation is pushing, cloud is changing things. The hyperscalers are really leading that. But still today, the drives are defining their own way of their own mode of access, where we have a standard, we have an interface. That interface defines a system and onward. But really, the cloud operators are requiring and demanding that the applications now be able to define how data is stored. Go back to those elements that I talked about before with where leveling and garbage collection, but most importantly, data placement. And that the reason why is because this, as I've alluded to earlier, affects their business and their ability to deliver a good quality of business. These things, keep hitting the wrong button, I'm sorry about that. These things that we kind of put in the bucket of orchestration, being parallelism, predictable latency, data placement, these things are all important elements in being able to define how the data can come in and come out and be done in a predictable way in a cloud environment. And this is where we have seen the hyperscale people are innovating with their storage, with their self-defined storage. Obviously, I can't, in a public domain, talk about the specifics that come our way, but these elements are all impacted by the definitions that we have the privilege of seeing. So, solid-state devices are digital, and these features that I have listed here should be able to be and can, from a technical perspective, be managed at the storage level through the application. And so much of this right now, I shouldn't say much of it, in a standard drive right now, these things are defined and delivered through a proprietary firmware program that is installed with the drive. And because it's proprietary, because it's firmware, the hyperscale environment, as the applications run, cannot reach down into the drive and say, "Thou shalt not garbage collect right now. Please wait till I'm done with this routine." The firmware is going to say something with an index on their hand, and now I'm going to do my garbage collection right now, whether you like it or not. So with this, as developers, you know that we have this new paradigm that is coming. The application really does need to be king in driving how the storage is going to be done, how it's going to be written, how it's going to be read. And we, as solid-state storage manufacturers and deliverers, need to be paying attention to this, and not pay attention to, but I would say embrace it. Cloud-based applications are the new normal and will continue to drive innovation. I'd like to share with you now, in the next slide, a kind of a little wistful, wouldn't it be nice to, set of ideas and somewhat of a industry call to action. But future versions of software-enabled storage should be able to, or wouldn't it be nice if they could support the following? Why couldn't you have a somewhat amorphous pool of storage that you could reach to with your software, that you could aggregate it based upon your workload, and you could deaggregate it based upon the workload needed? I've got a heavy one coming, I need a big pool. The second, why wouldn't you be able to say, of this pool, I want to be able to run one routine based on one standard and one on the other, and be able to do that simultaneously, and be able to have these capabilities and functionalities running simultaneously on this quanta of storage that you've been able to aggregate based upon your application and workload need, and be able to therefore, in so doing, control the latency in a deterministic fashion that fits what you need for that workload, for that routine. finally, as you're doing this, for the host to be able to say, okay, garbage collection will happen on this cadence. Wear leveling, we're going to hold that off for a while until this particular heavy workload's done, then we're going to go ahead and wear level everything out. So these are some of the quirky things of Flash that if you can control, we can take away that bottleneck of having to look like a drive and really open up storage to something that can be fully digitized and fully orchestrated according to the needs of what you're developing. So I'm going to kind of wind up one phase of this and move into another phase. The cloud is eating into the enterprise. I don't think anybody would argue this point. And the hyperscale cloud is dominant in that fashion, and they are software driven. And from a storage perspective, their application is king. This is the new paradigm that is coming, forthcoming. It's nipping at our heels, and something that I think we need to be able to embrace. And as I've alluded to before, I don't think I'm telling you anything that's brand new. I know I've had many of these wistful conversations in the past, but I do believe that this is something that now is at our door, something that we actually can begin to deliver in the near future. So at Toshiba Memory, soon to be Kioxia, we are exploring new ways how to make Flash more valuable in the software-defined world. So I said I'm going to shift phases here. So the phase was, where do we need to be going? What's the paradigm? What do we need to be doing? I'm going to be talking about now, with today's technology that we have now, how by embracing software into the storage area, into the storage device world, how can we increase the storage value? So I'm going to share two examples. One that I will, this is my own term, say is a drive-aware software. It's an actual product that we announced late last year. And the other one is software that we've worked on that is what I'm calling media-aware. In each of these, there's different things that you can bring to forward, different forms of value that can be brought forth by having either your software be drive-aware or media-aware. So let me talk a little bit about a software that we released last year called KumoScale. And KumoScale is software that deploys SSDs at cloud scale, and it also enables NVMe flash as a service. Kumo as a word in Japanese has different meanings. You'll see the Chinese characters next to them, but one is a cloud, and with the same pronunciation means a spider. See some Japanese people in the audience. Probably if you pronounce it a little bit different, you might be able to hear it, but to us Anglophiles, it sounds the same. One is a cloud, one's a spider, and you'll see why we picked this name as we go through the product. But KumoScale is a product that implements fast networked block storage as a service that is based on the NVMe over Fabric standard. It's architected to be able to work well in these modern container orchestrated systems, as well as the more conventional bare metal environments. Also, KumoScale, as the name implies, is built for scale, and it makes NVMe flash more efficient, more cost effective, and easier to deploy at scale, at any scale. Also, it's targeted for the on-premise cloud with compute nodes roughly 50,000 to 500,000 in size. And the primary purpose here is for a private network to be able to provide NVMe flash as a service. Let me talk a little bit about the architecture here. Pardon me as I build out the slide. Okay. So I'm going to explain what we call the KumoScale node, and this is the workhorse part of this particular product. So requests will come in from the network using NVMe OF commands. A namespace will be assigned, and that'll go into a mapper. This mapper then will map it out, convert the commands into NVMe, and then assign a physical drive. So this will be how the data path is set up. Once the data path is assigned, CumulScale steps out of the way and will not be involved in any of the data, will not be involved in the data path. Sitting on top of that on the user side, so first was kernel level, now we're on the user side. There is a management engine that will be talking with your provisioning and orchestration frameworks as well as the telemetry and logging frameworks. Those will come in via telemetry and other functions. Then what happens in the mapper will be brought up into the engine and back and forth, and this will then connect with your overall systems. When you translate that into the overall environment, from the provisioning or orchestration side, requests will come through. Those will go down to a mapping, come into the CumulScale node, and the functions I described will be executed. On the blue lines here on the left, you'll see the data path will be established. Then telemetry will come back into an analytics service that will then modify those nodes of n amount. And we'll be looking at drive health, drive endurance, and other things, and we'll orchestrate the mapping accordingly, and we'll feed that into the analytics source, which will then be brought back up into your provisioning tools. Also within the analytics area, there will be other health-related information that I talked about earlier that will come over to your management service, and based upon the design, there's a phone home feature that can send that data back into your other systems, your administrative systems, to be able to either look at your license usage, whether new drives need to be provisioned, and other things like that. So that's fast. If you want to learn more, we have some people here on the floor that can talk to you a little bit more, can explain a little bit more to that. Today, my purpose is just to show that in this way, if you're aware of how an SSD works, what its quirks are, what its strengths are versus its weaknesses, you can orchestrate a system like this that will stay out of your data path, but still allow you to deploy the drives in a much more efficient, cost-effective, and durable way. So that's first example number one, the drive-aware software. Let me talk a little bit about the second, which is the media-aware. In this case, I'm saying media-aware for better total cost of ownership. But certainly, with your creative minds, other values could be brought into place if your software is developed in a media-aware fashion. So we call this T-RocksDB for Toshiba RocksDB. If any of you are curious, we're not going to call it K-Rocks. We're going to stick with the T-Rocks name. But I'm sure everybody here is familiar with RocksDB. It's one of the more popular open source database engines, and is used in a lot of these databases that are listed here. RocksDB of itself has a history that goes back to Google. I think Facebook is the primary promoter of it right now. It's a very good piece of software. So I do want to be clear, what I'm going to talk about now is not in any way knocking RocksDB. We're actually trying to make it even better, from something that's good to better. Particularly within a hard drive environment with small database values, RocksDB as it is works great. However, if you deploy it into flash media or into solid state storage, there are some issues where greater value can be brought forth if this is modified to take into account some of the quirkiness of solid state storage. Particularly the way RocksDB is architected now, with a hard drive, it doesn't matter how many times you rewrite your data, it's not going to wear it out. Unfortunately, with a flash drive, if you keep rewriting data, you're going to wear it out. And RocksDB, as it stands right now, in the compaction process, will rewrite things enough so you get a write amp of up to as high as 30 times. So there is a better way. And we spent some time, I don't know if any of you attended Remington's breakout session. He's up here in front. You're welcome to talk to him after. But we did spend some time going through the code and saying, oh, how can we do this in a more flash-aware, flash-friendly way? Sorry, that's a tongue twister. And I think we were able to do so completely in software, no changes necessary to the SSD. Let me make the comment that I forgot about on CumulScale. For CumulScale and T-Rocks, in both cases, it will work with any SSD. We're not going to tie you to a Toshiba or soon to be Kioxia drive. You can use it on any of them. In the case of Kumo scale, if you do use a Toshiba Memory SSD, there are some added features, some other value adds that we can give you, but it'll work just fine with the Company S or any other SSD. And the same is true with RocksDB. You can use it with any SSD. So with that in mind, let me walk you through what it is. Here on the left, we have RocksDB as it is today, as it's commonly shipped, and that the keys and the values in the database are stored together, and they're rewritten together as it goes through different compaction layers. And as I alluded to earlier, that will result in a high level of write amplification, which is, to use one of our teammates' expression, SSD abuse. On the right-hand side, you'll see here that what we've done, and let me build this slide out now. With TRocksDB, we've separated the keys and the values. The key, obviously, taking an insignificant amount of memory, can go through each compaction layer and travel with that. But what we've done is we've put the values in a ring buffer and held those at the side so that they are there and they are not rewritten unless there's an event that demands some update of that value. And here at the bottom, there's a release old data function that allows that update to take place. But saving that, the data will stay as it is, and the database performance functions without creating excessive write amplification. So by being cognizant of media characteristics, developers can enhance or produce greater value within the storage. In this case, you can extend the lifetime of your SSDs. And this can be done, in this case, we've done this with no impact on performance. So when I kicked this off with our team, that was one of the requirements that I said is do not impact performance. Nobody's going to use this if the performance gets bad. And here's some data to show it. We've run multiple tests. Here on the far side is the write amplification. And you'll see the various test modes that we ran that under. And in the worst case, we had we had greater than 50% improvement in the worst case, and in the best case, significantly more. If you look at performance, the worst case was on par performance, and in the best case, although not as dramatic as write amplification, still, when you look at the random key reads, significant improvement in performance. So again, not to beat a dead horse, but if you look at what are the varieties, what are the strengths of the media and the drives, there is value with today's things that can be extracted and can be presented to your customers, to your efforts, by making the software more aware of how a flash solid-state drive or solid-state media performs. In the case of TRocksDB, we've made this open source. There's our GitHub address. We have in our table out in the lobby some takeaways that also have the GitHub address. I definitely would encourage any of you that are so inclined to join our project, improve, and contribute to the code, and help your solid-state storage get even more better. I had a term that probably isn't good for public consumption in my mind. So I want to conclude here and wind things up that, calling back to the beginning, there is a new paradigm shift. The cloud, our world, AI, and other things are really driving innovation in a level that I went from seeing things from cassette decks to, carrying everything in my pocket now. So, I mean, that's pretty dramatic progress, but it still seems to feel like it's accelerating, and I believe it is. And where we used to have a media bottleneck, now we have an interface bottleneck. And we have a form of storage, it's digital. Why not combine it with your software efforts and really be able to extract the full value? And hopefully, with our modest efforts and showing some examples from Kumo Scale and TRocksDB, that'll give you an idea of what can be done, plus more. And in all of that, solid-state storage has a big role to play. After all, it's digital. And it's cheap. But don't tell my CEO I said that. So all we need to do is, and I shouldn't say all, let's say, It's a big ask, but we need to make our solid-state media more software-enabled. So as I wind this up, I'll just say that this is an area for Toshiba Memory that is important to us. We're spending time on it, and we are investing in it, both in terms of software and of media. So I've shown 2 examples of what we're doing with software, and we're doing more. We do have other projects underway and in works. And we're also exploring ways that we can make the media more capable of interacting with software in a direct way, in a more direct fashion, so that we can help move into that new paradigm that we're talking about. I don't have anything I can share with you yet. I hope that there is a time in the future that I can share that with you. In the meantime, happy coding. Thank you very much.
Questions?
Scott Stetzer.
You mentioned that
Just a second. I need to bring one of my staff members up here. Scott, would you come over and join me on the stage? I want to introduce Scott Stetzer. He's been one of the leads in everything we've been doing. I have a liberal arts degree, so if your question is too technical, I'll kick it to him. If it's conceptual, I'll own it, but please.
you mentioned that the hyperscalers are driving a lot of the innovation compared to the mobile market.
Uh-huh.
To what degree do hyperscalers drive innovation versus the mobile market drive innovation?
That's an interesting question. I wrote this presentation from the perspective of mass storage, and definitely that is hyperscale driven. Within our own memory division, there has been a tremendous amount of innovation in storage, but that has been uniquely with how we deliver a flash in a more discrete fashion. So there have been a lot of innovations around the interface, around the physical nature of that. But I would say not, when you're looking simply at solid state storage, not as dramatic as what we've talked about today. I can hearken to one particular effort that we had in making the memory within a smartphone more directly accessible to the OS. But what we've seen is that becomes a tremendously siloed effort, and it doesn't really cross-pollinate to others, where in the hyperscale environment, we're seeing that the technology tends to spread itself across the industry much more quickly. It's my opinion. Anything to add, Scott? No? Okay, thank you. Any other questions?
Hello. So just now you mentioned that you are working on the RocksDB. I was aware that there was another work called Whiskey.
Whiskey, yes.
Yeah, which based on NeverDB.
Yes,
I think
Whiskey,
the idea here it's the same, right?
Whiskey was a key element that we referred to, and actually, I think if Remington would have referred to that, we actually talked to the people in that university that gave us some ideas. Whiskey, without getting into the details, does attempt to solve a different problem than what we're trying to solve, but the methodologies are very similar.
So you started out by saying that storage needs to be software-enabled,
Yes.
host controllable, and application-driven.
Yes.
And I think all of that makes sense.
Yes.
And it's the right way to go. But both of the projects that you talked about,
Yes.
Kumo Scale and RocksDB, still have the storage do all the data placement and garbage collection.
Correct.
So, can you share anything about what you see the future to be as, with respect to, and are there projects that you're working on?
Yes, there are projects we're working on, and I can't say much more than that publicly. But as you mentioned, the CuML and TRocksDB do work with today's conventional SSDs as they exist today, where, as you said, a lot of the housekeeping functions are still done within and driven by the firmware within the drive. And today was more an example of even within today's paradigm, there still is added value you can do by having your software be more cognizant of either how the media works or how the drive works. Your question was, well, what's next? I think over the last 2 years, we've seen a lot of different efforts on making solid-state storage more software-enabled or host-controlled. And without naming names, which I don't think would be appropriate here, we haven't seen one that's yet really provided the answer enough to be able to get up to scale. And all I can say at this point is we are looking at ways to do that I believe in the future will enable that. But I can't really discuss more of it than that. There are continuing efforts that I'm aware of right now in the market to be able to unlock this particular paradigm. And if we don't succeed, somebody will.
Okay, we're out of time for questions. Thank you very much.
Thank you.